So in this video I want to go through something probably isn't discussed a lot as you're learning subnetting, and that's what network address zones are. And I'm going to start with IP4 addressing again. So IP4 address, it's used to identify each network connected device uniquely on the network. And IPv4 is a 32-bit dotted decimal value plus a subnet mask. So with the subnet mask is just denoted with a slash typically. The subnet is a single broadcast domain, as we've discussed, and the routers forward packets between subnets. And that's essentially all layer 3 architecture. The IP address classes, these are all of them. We've already discussed this, what this table is. It's kind of a static table, includes every IP address available and how they're allocated per class address, and how the subnet mask affects what is the network address and what is the host address. And this is all private and public addressing. Most assigned addressing that you'll have to administer will be private addressing, and that's another range I'll discuss. It's from within this address class, between 3 address classes. It's a subset of them, and everything else is public. Public addressing is ISP assigned, so it's something you administer a single address that's outside of private addressing, but is still part of all these address ranges. So private IP addressing, it's called RFC 1918. You hear that a lot, and it's all private internal routing domain addressing, and that's where most of the addressing is assigned from. If you look on your local network, it's going to be 10 dot addressing will be often most of what is assigned to the private network address range. Sometimes on branch networks, smaller ones, you'll see 192.168 used a lot because it provides fewer network addresses. I'll go into that a little bit more. And there's 172.16 as well, so this is very key to know these ranges. So the 10 is all the 10 dot address, so not 11 or 12, just 10. And so there's the subnet mask. So this address, you can assign anything from within this range, and you have to start using variable length subnet masks to actually effectively make use of what's all that's available there. 172.16 to 31. So within that second octet, and that's a class B address, so it's the second octet again that we're working with. And so it's 16 through 31 is what's assigned. Now that's actually better than 192.168. Now this is the only address available. It's 192.168 1 through 255. So you'll find that 16 through 31, that's 31 addresses. This is only one. And this will make a little more sense as we go along. So subnet mask is 240 to mask off 16 through 31 to /12. And this is subnet mask to include just the 192.168 range. So it's private addressing, it's company managed, it's your inside network, and it's just for private routing domain only. Public addressing is anything that's not private. It's ISP assigned and internet routable. So you can route this, you can route public IP addressing if it's not within any of these ranges to across the internet. So network address zones. So here, for example, is a branch office, and typically, so it's got private addressing. It has to be private, and it's private right up until this WAN interface here. And in this case, I'm showing private, but it could be public as well. So in this case, it's extending private right through to the data center router. And the data center router always has an internet connection. That's the public connection, and that would be that interface there. So private to public there, and the translation between the two is typically with NAT, network address translation. The DMZ is mixed. It's based on the network design. So you could have public addressing here, here, and here, for example, and maybe even here, or you could have private addressing there and there. So it could be a mix. It's based on where you want to separate the boundaries between public and private addressing. That's why it's called a DMZ. then the inside data center network is going to be all private addressing. And that's basically where most of it is. The branch office sometimes has a public interface, so you have to translate between private and public addressing there as well. And here's an example here of private addressing. There's your ranges that you have to assign. So 192.168 addressing, so there's .10, .11, .12. Don't concern yourself with the 16. It's just that it's talking about a range more than subnetting. And I'm trying not to make it too confusing. Just know that you've got subnets in the third octet between 1 and 255. And so there's a lot of subnets there, but with a bigger network you'll run out of those fast, after 255, based on how you're selecting them. And so 10.10.10, so this is using a Class A address with a 30 subnet mask. It's variable, and that's on a WAN address. 172.33, that's outside of this Class B 31 address, so anything past there is public because it's not in the private range. That would be assigned to the outside interface. And the DMZ is just a mix of private and or public based on the design itself. In VLAN 100, this could be a server subnet with, say, 50, 60, 70 servers, and it's using 172.16.2.0, and so there's 172.16. And again, don't concern yourself too much with the subnet mask. This is not a default mask for Class B, so I'm using variable length subnet mask for this. Even though it's a 24, it's a Class B, so it's still considered a variable length mask because it's not 16. So I've just added, I've included variable length subnet masks as a part of this example. And the 172.16 here, this is again that range there, 172.16 to 31. And there's an example of another VLAN, say some user VLANs, VLAN 9's got 100 desktops, and it's using the 1.subnet. So a lot of this is just to show you the how you're moving between private and public and in mixed zones. The VLAN is a layer 2 broadcast domain. So in this case, I've talked about broadcast domains, and they can be layer 2 and layer 3. A VLAN is a layer 2 concept, although VLANs are often mapped to a subnet. You've got, say, 100 desktops there, and they're assigned, each of those 100 desktops are assigned to a switch port that is assigned VLAN 9, for example. But the IP address of the desktop is going to be part of a subnet. So there's an association there, if you want to consider it like that. So the VLAN is a layer 2 broadcast domain, so it's equivalent to a subnet as well. And there's four different VLANs, so there's 4 different broadcast domains, and each one is part of a subnet. And a router interface is a layer 3 broadcast domain, so it's all about, has to do with the interfaces. This router to this layer 3 switch, this is a layer 3 broadcast domain. This is one subnet is different from this subnet and different from this subnet. They're on different subnets, and the router routes between them. You can't have these two in the same subnet. It's not a legal networking design. So they're layer 3 broadcast domains. So they're not VLANs. They're actually IP addresses assigned directly, and they route layer 3 IP addresses. So these are routers, not switches. Layer 3 broadcast domain. And there's 3 of them here. The previous example had 4 different layer 2 broadcast domains. Each VLAN is a layer 2 broadcast domain. So VLAN versus subnet, kind of what I was saying about how things are mapped. Typically this is what you would do. You would have 4 different subnets. These are classful. This is a Class C address, so it's using /24. There's .1, .2, .3, and .4. There's your 4 different subnets, and each one has its own VLAN as well. So VLAN 9, 10, 11, and 12. So the host is assigned to the subnet. So you've got a host address of 1.1 within this subnet. So it could be 100 or 25 or something. And the host is assigned to a switch port. So the switch port it's connected to, if the switch port is configured for VLAN 9, then that host is in that switch VLAN, based on the fact that that's where it's connected, or the actual switch configuration. The switch port is assigned to a VLAN, like I just mentioned. So it's a one-to-one subnet mapping. Each VLAN has its own subnet. It's kind of moving from layer 2 to layer 3, if you want to think of it like that. But not necessarily. In some cases, you can have no VLAN to subnet mapping. You can have multiple VLANs on a common subnet. In this example, there's VLAN 9, 10, 11, and 12. They're separate VLANs, and they're all assigned to the same subnet. And you can do that as well, because a VLAN is a layer 2 concept and doesn't concern themselves too much with layer 3 information. So you've got these 4 different layer 2 broadcasts. You could have maybe 100 desktops on each of these VLANs, and they're all assigned to the same subnet, and that's done sometimes too. So you break up the VLANs because you want to minimize the layer 2 broadcast domains by having different VLANs, but they all are assigned to the same subnet. And so multiple broadcast domains. In this case, I'm showing you layer 2 and layer 3 broadcasts. We know that the VLAN is a layer 2 broadcast, and any interfaces between neighbors is a layer 3 broadcast domain. So there's actually, in this case, there would be 3 different subnets, and that's subnet 4 and subnet 5. The subnet 5 would be the WAN subnet. Subnet 4 is just these 2 interfaces here. Anytime you connect 2 layer 3 devices, they have to be in the same subnet. In these kinds of broadcasts, the MAC learning is something that occurs on switches, not routers. So they have different kinds of broadcasts. ARP requests happen on switches as well. They also get forwarded to routers. And there's DHCP discovery. You've got 300 devices all sending out DHCP. And you've got routing message. So there's a lot of busyness of broadcast activity, and so you really want to kind of minimize that and manage it properly. And broadcast domains permit you to do that.